There he is.
Hey guys.
Pressure. No pressure at all.
No pressure at all.
We've been hyping you.
There's any light in here. It's so late.
I love it. Yeah.
You guys hanging in there?
Yeah, we're doing great.
Yeah.
Yeah.
Paul's still on early time. I got the early time with Paul.
Oh yeah, Joseph, you're on East Coast time, right?
Yeah, East Coast. Yeah.
We're in the same time zone, me and Will, though. So
yes, we are. I'm in Oregon, and you're in LA.
Yeah, yeah. So, Will, have you been able to watch any of the summit at all?
Oh yeah, I watched every day except for earlier today. Amazing, some of the stuff, just absolutely amazing. I loved Andrew's stuff that he showed. Of course, that makes a lot of sense to me, being a makeup effects artist. So 100%. That was great use of the technology. And what else did I like? The Wayne Barlow sculpture.
Oh
was
yeah,
amazing.
From Stephen Saunders.
I've loved all Wayne stuff for so many years, and that was an amazing sculpt. That was like a one-on-one sculpt. That was perfect.
Yep. Well, tell a little bit about yourself so people know where you're also coming from, because you've got like a house length worth of a resume in the film industry.
Yes, it's a big list for sure. That shows my age. I'm like, I looked through the list today, and I was like, did I work on that? I don't remember. But yes, I'm a makeup effects artist. I've been in the film industry for almost 27 years now. I always say 25, but 2 more years go by. 27 years now. I've worked on a lot of films. Probably the most recent has been in the Marvel universe for the past 4 years, I'd say. And my responsibilities on that show are usually just Gamora. So Gamora's my gal. Yeah, which is great. Zoe is an amazing to sit through the crap I throw at her. Which is, it's not too bad. But when we were doing Curious Case of Benjamin Buttons, people will be sitting in our chairs for like 6 hours. So you really have to get along with the people that you're spending all those hours with. And so what I'm showing today has very little to do with it, other than the fact that, like you said, you're a fan. Everybody's a fan. Everybody in the industry is a fan. We got in the industry because we're fanboys, right? Mm-hmm. So absolutely, everything that you can imagine was always inspired by something that we saw at some point in our lives and went down that road. And that's what happened to me. I definitely saw a television show. I'm going to age myself again. I saw a television show when I was a kid called Lost in Space. It was from the 1960s.
Danger Will Robinson.
Exactly. Not the remake. This is back to '66.
The remake doesn't count, Will. The remake does not count.
No. And why? It was such a beautiful robot. What happened? I don't know. So that was my interest in robots for sure. That stayed with me for years and years and years. And then when I was in the film industry, I started finding lots of people, usually prop departments, and people who were like, "Hey, I got this piece from the Lost in Space robot." I'm like, "What?" So I started getting into collecting parts and actually reproducing that robot myself. So I don't know if I could bring this up. I'll show you. So this is the robot. Can you see my screen?
Yes. Yeah.
Okay. So that is it. Wow. Right. So impressive. But it really stuck with me. It stuck with me for years, and that was my beginning on starting to get interested in robots. So but while I was building that, I was actually teaching myself robotics at the same time, because I didn't want mine just to sit static in the corner. I wanted it to be animatronic. So a lot of my background in makeup effects comes from animatronics. Back before CGI replaced everything, we had animatronic puppets in the 80s and 90s, and that's kind of my background when I first started in the industry in '93. So it was all about servos and making things move and doing all those kinds of things. So robotics was actually just one little step to the side. It was exactly the same techniques, the same ideas behind it. It's just the software that runs it is different. You'd have the RC remote controllers to get a puppet to move on set. And what I'm doing is actually taking software, injecting artificial intelligence into it, and taking everything that I'm building inside of ZBrush and 3D printing. So it was like several things happened at one time. It was 3D printing, ZBrush, robotics, and I squished them all together, which I'm really good at. That's like the one thing that I'm really good at, taking all these really weird things and kind of smush them together and to make something new. So that's kind of my background with the robots. But with a little background on ZBrush, when I was first building the Lost in Space robot, I was kind of hearing about this software called ZBrush, and I don't even know what version. I think it was 3.1.
Okay.
Yeah, so it was a way back. But as a makeup artist, I was like, finally, because I did some box modeling inside of Lightwave from years and years ago, and we're doing stuff, and it's like beep, 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 you know, yeah. But to do something organic was impossible, right? So as a makeup artist, I grabbed a hold of that and knew that that was going to be a tool. Yeah, I had, you know, lots of people who said that's not going to be a tool, but I kept teaching myself and watching as much as I could. I don't know if YouTube was that big then, but I don't think certainly nothing on the internet for that. So I played around with some stuff and did you know, just some ideas for makeups and just, you know, little characters, little fun things. And that was great.
Those were in version 3.1 you were just showing?
No. So, some of those, probably the earliest one was, no, none of these. Actually, that was not 3.1. But later, as the software matured, I was able to do that, some of those things, because there's fiber mesh in there, there's Dynamesh in there. Once Dynamesh came around, that changed everything for me. That changed everything. And I started working with Dynamesh when it was, you know, 2K, when you guys first came out. And so my first robot, Alan, started out with just 2K. And I was like, if I want to build a robot, it's really important for subtractive materials. Like, how can I, when I'm doing something, you know, traditional from clay, you got to build all these separate molds to get one thing to nest inside the other. So for me, it was kind of like, hey, can I take this face and subtract this skull from the back of it and start building up all these kind of layers into something that is functional? But the problem was, at that time, my idea was I was ahead of the curve there, because there was no affordable 3D printers at the time.
Oh, you're right.
So I kind of spent like a couple of years, maybe a year and a half, just kind of fiddling around with subtracting things. And let's see, we'll go to Alan, since he was the first robot that I did. This turned out after about a year and a half of fiddling around. And what Alan kind of showed me was that it was possible to be able to take ZBrush and do these kinds of things. And it was about, you know, getting, you know, this part. I knew I wanted to make it silicone, so it was going to be translucent, so you could see all the understructures underneath of it. So this had to be something that was moldable, but it also had to be something that nested perfectly on top of this shape. And so I knew all the mechanics were going to be inside here. So that was, again, same kind of thing, where I then have all of the mechanisms for the eyes and everything's inside there. So it did exactly what I thought it would do, which is just nesting all these parts inside of one another. So then a company called 3D Systems came out with the first prosumer 3D printer. It was called the ProJet, and it was $15,000. And I bought it. It was the first resin printer, actually. And these parts were big enough that I knew that I wanted to do them out of resin. So I actually bought that printer, and it cost $800 for 2 liters of resin in it. So
$800? Holy moly.
$800. I couldn't hardly afford to even start the machine up.
Oh my
God. I needed to make sure in my mind that all of these parts were just exactly as they needed to be, because to reprint them was going to cost me $1 zillion, right? So that's what I did. This is actually the first prototype. This is the first one that came out of the box. A lot of stuff that I learned was the parts warp a lot, at least with that resin. That resin was really gummy when it came out of the machine. Like, it was a big machine, but it took forever for the resin to actually cure. So while it was just sitting there, it would deform. So I started actually adding in these little bars to kind of keep it from misshaping a little bit, which helped a lot.
Can you zoom into that? Can you zoom into those? So
yeah, hang on. Sorry, I'm sliding over to the side as I always do when I'm using ZBrush. Yeah. So I just added these little bars in here and here, and this helped the structure, because if you think of it, it's like a horseshoe. So that horseshoe shape wants to deform because there's nothing to hold support in there while it's curing. So the important thing was that I wanted this front shell and the back shell had to match up. And, you know, I put a lot of magnets and stuff. So I had to build in these little holes to put the magnets in, because I don't like what I call space screws. I don't want to ever see a screw. So most of my sculptures, most of the things that I design, you don't see any external screws, because everything's magnetic. So a lot of when I'm designing, I make sure that I got a lot of that inside there. So this was the first robot that I built. I'll go into a little bit more detail and show you the robot running towards the end of the show. But this proved that, first of all, the ZBrush was an amazing tool, not only for all the organic stuff I was fiddle-faddling with, but this proved that I could do hard surfaces and still organic stuff, right? So the face is organic. Good luck with trying to sculpt that in Lightwave Modeler. So it definitely proved my point that this could be kind of like a nesting object to be able to create these robots. And so after this robot, I formed a company in 2015 called Robomotics. And the company is kind of an R&D company. I'm based around like robots for artificial intelligence, like universities using them and so on and so forth. So I used this as my first prototype, and then I made other prototypes after that. And those prototypes utilized a lot of really hard machinery parts. Like the stuff you see in here, most of it I tried to use plastic just to see how well it would hold up. But I knew if I was going to go with something that was going to be in a museum or somewhere else, that a lot of these parts had to really be manufactured out of a much more solid material. And in this case, it's aluminum. So when I'm working, the first thing that I do is I kind of have to reverse build things. Sorry, my brain doesn't work this way. Okay, here we go. What I have to do is bring the real world into the computer. So all of these parts that you see here are actual physical parts that exist that I have to bring in order to build my robot around these existing parts. So I actually source all of my parts first before I actually go in to even design the robot. That way I know that these parts are going to be the right parts that are going to fit inside the robot. And I'm not going to have a problem with, say, you know, with something not being able to fit because I didn't incorporate it into the design. So,
did you get these from the manufacturers? Did you build these?
Some of them yes, some of them no. So great question. So this servo here is an actual robot actuator. It's called Dynamixel, and it's made by a company called Robotis in Korea. This robot, I mean, this motor alone is $600. It's a very expensive robot motor actuator. This was an STEP, a step file that they had that I downloaded and was able to pull that. So I convert my step files over to STL and then just import them right in, and they're one-to-one, because everything, you know, lots of people way back when I was talking to people about hard surfaces, like, you can't do hard surface in ZBrush. It doesn't have any measurement system. And I'm like, yes, it does. It's millimeter to sub-millimeter. It's perfect. And I would sculpt the part, print a part, and show them it's one-on-one. This is no different than any CAD program. You just have to. What are you
using to convert your step files?
I was using 123.
Oh, okay. Yeah.
Yeah. I think it's called 123D something from.
They went through 5 names. I know. Yeah, I know what you're talking
about. Yeah, it's gone now, but it's something else to supersede it from Autodesk. But there's lots of other converters out there that you can use. Probably even some free ones as well. And this is really helpful for getting all of these parts inside of ZBrush. And a great example is, I don't know if you guys ever heard McMaster Car before.
Mm-hmm.
When I was working in the industry, we would have a catalog that would be in the shop that would be about 3 inches thick, and every page was like onion skin. This company has everything that you can imagine. Every kind of bolt, every kind of washer, bearings, U-joints in this example. And every single thing online now is inside on their website that you can download. So I can go and say, hey, I want this U-joint. And all I have to do is go over here and find step file and hit save and download it. It comes in as a step. And I switch it over to STL. And this, I mean, they have, when I mean they have a lot of stuff, they have zillions of things. So every single one of these parts is there for downloading. So if you want to if you want to bring something in that's going to be a mechanical part, you can download it, or you can each download it and send it out to be an actual object.
You want to put that link in our chat, and we'll share that with everybody, so at least they have that too.
Absolutely. And
yeah, I can get it.
Okay. All right. I
Yeah.
think that's getting it. You're getting a lot of questions starting to pop up. Like,
okay, hit them at me, throw them at me. I know my path here, but I have a tendency to go a lot to the left and to the right. So bring me back with a question would be great.
So can you show us your measuring technique when you're converting from CAD to these pieces?
Yes, absolutely. Well, you don't have to convert as long as you stay with millimeters in ZBrush. Then and don't change any of the units. Then all these models coming in are coming in exactly as millimeters. So this is the U-joint that we just saw, and this is exactly that size. So if I go to move and I go back to our old fancy transpose tool, and draw that tool out, you can see that it has 85.75 up here.
They're not going to be able to see that, unfortunately. So on the top our things for the stream is covering it.
Oh, okay. Sorry. Okay. So up in the upper left-hand corner, there's the units measurement there. And dragging this out will tell you exactly what that size is. So another example is this bearing that I have here. And this bearing is in the physical world.
That one.
Don't worry about that. Okay. Wait a minute. Okay, let me go back to...
we can go full screen on your webcam if you want. You want to go full screen on your webcam?
Yeah, real quick.
Okay. Go ahead, go full screen. There you go.
Okay, wait a minute. Whoops. Sorry, guys.
No worries.
I can't see my...
We're full screen on your webcam right now, so we're not seeing your screen right now.
Okay, how do I get back so I can see my webcam?
You should be seeing it in the program.
I see.
So try your browser. Go to your browser. Maybe you're not on the browser because
okay, hang on.
It's happening in your browser.
There we go. Got it. Thank you. So sorry.
Yep.
Perfect example.
Okay,
this is it. This is that.
There you go.
There you go. So this is that bearing. This is the physical bearing, and then you're gonna want to have a fancy caliper, and you're going to be able to measure all of your measurements, and then I'm going to be able to reproduce that in ZBrush. So I just duplicate all this stuff. So I have servos. Let's see if I can get in.
Oh, fancy. Oh, there you go. It's fancy.
Yeah, there we go. So we got nice servos that we could put in. We have a standard servo here, and then we have a micro servo here. And basically all I'm doing is I'm taking literally just measurements off of everything and reproducing it in ZBrush. That's a close-up.
So you're recreating some of those pieces from scratch then. You're just using those measurements and recreating them.
That's absolutely right. And that is what I call sourcing. And I have to source those materials first because let's say if I want, for instance, on a robot, I want an arm to lift up, and the arm has to, it's a shoulder joint. The shoulder joint has an enormous amount of weight to carry because as the arm is going up, there's a lot of weight there. So I need to find a motor that's going to be able to do that first before I design the robot, because if I can't find a motor that fits, then I have to find another motor. And if that motor isn't the exact same dimensions, then I have to then I'm screwed, because I've already started building the robot and it's not going to fit, and I have to go back and redesign it. Sure. So that's the first thing I do. And when I'm done with that part, I end up with some parts. This will be this is the beverage dispensing robot that I'm building for the YouTube channel. This robot is 6'3", and it's basically voice activated. You're going to ask for a Red Bull, or you're going to ask for a Jägermeister, or you're going to ask for wine or beer, whatever you want. Inside the robot will dispense this for you. So building, awesome. So building this robot, you have to start with a really solid structure, right? So all these parts, again, same kind of thing. All these parts are designed in ZBrush with all the measurements, all the holes are cut. These parts get saved out as DXFs. They export them out as OBJ, but then I have to convert these to DXF. And what DXF file will allow me to do is to get this water jetted out on these aluminum plates, come back to me an 1/8 of an inch thick with all these holes that I have. This lines up with all of the parts that I need. So perfect example of the perfect example is
do you have your own water jet? You don't have your own one. Do you have your own?
No. These get sent out to a local place. Sent out to a local place. But here's that bearing that I was just showing you guys. So this bearing, because I took all my careful measurements when I designed it and built it in ZBrush, these holes matched up perfect when I got the water jetting back. So yeah, this gets done at a local in Portland. But then for Alan, the perfect example of Alan. So Alan had a lot. This was the next version of Alan where I needed to go with stronger parts. So these parts are actually milled aluminum. So if you can go back to my camera. So this is that part. Let me see if I can zoom in again. There we go. So this part is completely machined, CNC machined right out of aluminum. And this was designed in ZBrush, not in a CNC machine. This is ZBrush. And then this part goes inside there. And so again, this goes back to that nesting. There's some of this you could do in CAD, but a lot of this you can't do because of this beautiful nesting of getting parts going in. So these are CNC machined, so they're designed for, I have a robot that's in Kuwait in a museum that teaches visitors object recognition. So for that to run 7 days a week, 12 hours a day, nonstop without breaking down, which so far it's been in there for 3 years and it hasn't broken down, I had to go with some pretty serious parts. It's very heavy, but it's living. It's still surviving.
Do you have any suggestions for where to learn about animatronics and robotics besides, like, they're bringing up Stan Winston School? Do you have any other places that are good places to go learn about this?
No. Let's see. That's hard. Because robotics is kind of this. It's kind of just still on the horizon. I wish there was, but part of the problem is that a lot of robotics is expensive. I'll tell you right now, there's nothing cheap about it. Even just doing robotics for kids, it's like limited to Lego Mindstorm, because it's just so expensive to get, parts and motors and things like that. So I'm hoping that part of my channel is doing that. I'm teaching people about what to buy and how to buy, and eventually Alan and his female counterpart Elena, both the robot heads, are going to be kits that people can download and print themselves and put the robots together, and then
that'd be awesome.
And I'll have the programming already done, so all in the cloud. So all they have to do is download the program, and their robots are up and talking to them, in a matter of days.
So you're having a lot of precision questions. A lot of people asking.
Okay. Sorry. Yes, you asked me that question before. Yes. Okay. Let me talk about precision in the way of my precision.
Right.
Good enough is my precision. I am okay. I'm not 0.001.
You were talking about, had the bearing. How did you get the right size and make sure that that's the right size hole for the cylinder to match the other parts that you were getting made somewhere else? What did you do?
For the holes to be cut?
Yeah.
Yes, that's Dynamesh.
So make sure when you're making it in ZBrush, like that bearing, you made it in ZBrush from scratch, right?
Absolutely.
So the holes in those bearing,
yes,
you're just using a cylinder, I'm assuming. So they're asking, how did you get the right size cylinder and get the positioning correct so it'd match up with all the other pieces they're going to stack?
Because I also built the other pieces, so I can move this part. Let's go back to the let's go back here.
Yep.
So if I measured this part, and then all the holes line up because these holes were here, and then on this side, I made some pegs with just some primitives.
Yep.
And those go in, because it's okay to have a little bit bigger hole, or even smaller holes are fine if I go back in and drill them out with a drill.
Sure.
So these holes were all lined up with this piece that I brought in first. So all these holes match up perfectly.
Dynamesh? Is this Dynamesh?
Yep. Yep. You bet. Everything's Dynamesh. I started using live Boolean, but I'm so freaked out when I get so many pieces that I try to limit it down to a couple of live Booleans at a time. Like I'll do 2 or 3, bring it back in, 2 or 3 back in, but then I'm still always like one version away. Like I'm still like learning ZBrush, 2019, all the new things that are in it. So I'm just always like a year behind on learning what other cool things, but live Boolean is a game changer, as you guys have said a million times on the show. It's like, it really is absolutely astounding. And I like the idea of being able to see what I'm going to get before I push the button. Like when you Dynamesh it, you sometimes have to go back, move something, Dynamesh forward, go back, move it, back, forth. With live Boolean, you can go in and show exactly, I can see exactly what part that I'm going to get.
Yeah, I just want to add something to this, because Will's talking a lot of stuff too, like that we normally don't see inside of ZBrush, right? Like this is what Druss and I have been trying to say.
Right.
There's a lot of ways. By the way, there is a plugin, people, on our webpage that's, what did you call it, Druss? IMM, what is the name of it? I'm going blank right now.
Anyway, I got so many up there. I don't know.
Druss made an actual plugin. You guys could draw out insert mesh brushes with the exact size to millimeters.
Yeah, I think it's draw size something.
IMM draw size, I think is what it's called.
Now, see, that's what I have to have. That's perfect. So here's another example of this bolt right here. Another thing, you can also just do this. So this bolt right here is downloaded from McMaster Car. It's 630 seconds. It's a 630 second bolt. So that bolt is 630 seconds. I know that when I go to put my bolt in it later, that's going to be a 630 second bolt, because so you can have whole libraries with everything stored just like you would in a CAD program, with all of your bolts, all of your bearings, all of your motors, all of your, every little single part can be built into a library that you can then go in and grab pieces and parts from to then start building the framework for your robot prior to going into working on the shells.
Yeah, I do the same thing. I do, like when I'm doing a toy, if it's going to be like a 2mm pin, I just make it right out the gate a 2mm pin and have it.
Exactly, absolutely right. And that's these little guys right here are when you want to recess a bolt in with the head. So let's say if I have a piece of aluminum or something, I can actually recess this larger cylinder into whatever. It could be plastic or whatever. But again, this would be if you have space bolts. I started talking about space bolts earlier. A space bolt is just a bolt that's visible that looks like a hex bolt or Phillips head or something like that. I hate that, but you could just recess, using this larger portion in dynameshing it into whatever part you're building, and you're always going to have that recess in. If you have it CNC'd, that CNC recess will be in there for you. If you're 3D printing it, you can 3D print it and have that recess in there for your bolt as well. So some of the other parts that I showed you then were, so here's a micro servo, here's a regular servo. Some of these stuff you can get off of Thingiverse. If you have the exact same model, even if it's not, you can still go in and adjust a little bit, save you a little bit of time. This is a gear motor that I have that uses the bartender robot uses for his shoulders. And I just took, again, just a basic idea of what the motor looked like. If you go back to
What resolution are you using for those when you get back into ZBrush? Your Dynamesh when you get back in there?
It depends. I don't ever go all the way to the max. It depends on that volume, how big or small that volume is. It's never the same when I get in there. Sometimes I get something that's old, and I'll be way off on the Dynameshing, and I have to kind of go, and I'm scared to kind of change it because I'm scared my sizing's going to change. So that whole volume around my object with Dynamesh still makes me scratch my head a little bit. So sometimes things I need to go up higher, and some things I need to go like 80, and it Dynameshes. So it just depends on where that part is in the space. But anyway, same. So I just get a kind of a general sense of the size of this motor by using just primitives to give me this. And that way, as I said, I can stick that in the robot, and I'm going to know right away whether that's going to work or not. So that is kind of the process to get me to bringing the outside world inside.
Okay.
Then once I'm inside ZBrush and I'm happy and I've got my little frame, and my frame looks like it's going to be sturdy, then I go into a couple of things. I'll show you the this is the final robot. Oh, it's chugging.
He's working on his YouTube channel, everyone, too. So if he doesn't show it tonight, are you going to show?
Oh yeah, I've got them all set up. I'm hoping to be done at least 10 minutes before my time's up, so I can show you those robots. They're all set up and ready to go.
Awesome.
So here, okay. So when I started with this whole idea, it was a sketch that I did 20 years ago of like a bartender robot. I was like, oh, that would be really cool to do for the YouTube channel. That's my first robot. 6'3". What was I thinking? It was like ridiculous to do this for my first robot. I'd never done mechanical arms before, so that was a big, huge challenge to kind of figure out how to do all of that. But once I had sourced all of those parts, before I got to this final look, which is kind of like a K2SO robot.
Yeah, love them.
Which I love K2SO, and I kind of
awesome. Yeah.
Yeah. So that was kind of the idea or concept behind it. But before I did that, I went in and just did lots of crazy, silly stuff. Like I go in and just kind of like really quickly, I give myself 10 to 15 minutes to just kind of Dynamesh and carve away different ideas and concepts for different things. Originally, this was kind of the original head I had in the sketch, but I decided it was too much like a helmet. So I decided, I don't want to do that. But again, I just kind of like kept coming back to this literally like 5-minute throw together that I did. I was kind of like, hey, I kind of like everything Star Warsy, and this was kind of Star Wars inspired, has this kind of outside shell, and then underneath you see all these mechanical parts just kind of like hanging down. So I kept going back to that because this just felt more Star Wars-y to me. And so that quickly became that became the kind of the theme for this robot. And I just kind of followed it through. A lot of this stuff is functional. So there's servos down inside the chest. Let's see if I can move this part out of the way. There we go. So there is a servo that fits in here and a servo on the other side that's connected to these neck rods. And these neck rods move the head left and right. And if you move them both at the same time, it makes the head go up and down. So this was a functional part that I kind of added into it. It's kind of going through this neck piece. And then I had a learning curve with the 3D printing. Let me talk a little bit about the 3D printing and challenges that you have when you're dealing with parts this big. I mean, they were big parts. So I bought a printer called the Creality CR10 Max. And it's big. I did all the parts in PETG, and PETG doesn't warp as much as some of the, doesn't melt as much as like PLA does when it's in the sunshine. So I wanted to make it out of PETG, but it does warp a lot. So I had some challenges with that. But when I'm designing, I also have to think about where these parts, how these parts are going to print, where I'm going to cut them, so that they fit on the printer, and then how I'm going to reassemble them later. So an example here, if I can get, let's just go so we don't kill the computer. Perfect example here is on this chest plate. I put these little, you could see how dirty they are. It doesn't, you would be amazed at how much is good enough. Look at all this, you know, junk behind it. This is not CAD. This is not beautiful, flat, incredible surfaces like Paul and Joseph do. This is literally good enough. And so you can see where I Dynamesh, it's even got the little puffed up lip around it. It's just like, it's crap, but it works. I know exactly what works at 0.3 microns on a printer, and 0.3 microns is quite large. So it doesn't pick up a lot of detail. So what I do is I put a 2mm hole in these, and then I take some of the filament and put into the holes, and they're aligned on each side so that after the print comes off, I can put the two pieces together, kind of like peg and groove. Mm-hmm. And those pieces go together perfectly. And I can do that with Dynamesh. I just put my little piece of filament in there, Dynamesh it out, and then I've got my holes. Those holes print in the print, and then I can assemble those two parts together. Okay, let's see. Here we go. Okay, let's see. So as far as parts, I build a lot of stuff myself. I'm not going to lie. Definitely, if there are kit bash parts out there, I'm going to go get them. It reminds me of the old days when you were a model builder and you just built things. So I build up libraries of pieces and parts. Some of them, I try to do, very less than I would normally do on something that was going to be like, if somebody was doing something for a game or for a film, I don't want to do anything like that. But, it's great going to ArtStation and supporting artists that have parts on there. If there's something there that gives me a start for like a foundation, then I'm going to definitely go for it. It's about speed. ZBrush is 1/3 of my process. I have to design the parts, then I have to 3D print the parts, then I have to assemble the mechanics and program. So whatever I can go as fast as I can, then I'm going to part. So I'm building these chess pieces out, and then like this little piece here is like a piece that I got somewhere on ArtStation. And the reason I have these little parts kind of built into the robot is because the 3D printer doesn't print that high of a resolution, especially at 0.3 microns. So I want lots of little tiny parts that are high resolution that I can print on my resin printer. So I will pick these little places just so that if your eye's moving very quickly around the robot, you can see little pieces and parts here and there that give you a higher value with having detail versus the parts that are lower value that are printed on the FDM filament printers. So that's kind of what I do. I did the same thing on these little side pieces over here. They were all printed separate. Whoop, there we go. And one of the other things, again, functioning here, the back part where the computer, so the computer goes in here. There's actually a touch screen that comes in the back, that's in the next episode coming up, episode 5, that goes in here. But to get to my bottles that are on the inside, I was like, oh crap, the computer's in the way. So I built this whole mechanism it's just hinged right here, and this pops up, and then this back door opens so that you can then pull the tray out and get to the bottles and change the wine bottles or whatever you have inside the robot. So if you go back to my camera, where am I? There we go. So this is that part. And it, again, magnets, right? So this kind of tips up like that, and then it comes down and just clicks back into place with magnets. Again, one of the reasons why magnets are amazing. And look, no screws, which I hate. So that is, that definitely is things that you have to think about when you're going into the design phase of this thing. And when it starts coming together, I really have to think of it in pieces. I have to think of it as modular pieces. If I think of it as a whole robot, my brain explodes. I have to think about the head as a single unit, the neck as a single unit, the chest, the back, the computer part, the arms. The arms alone, I started this whole robot and hadn't designed the arms. And I got myself into a pickle because it took me almost 2 months to design the arms because I screwed myself by making the arms so thin. So I wanted to do, like, if you look at Star Wars stuff, they have really gangly, really skinny arms. And I was like, that's what I want, but I hadn't sourced any parts yet for it. So it became very difficult to get the amount of motion. There's 6 degrees of motion on this arm. So getting everything to kind of work together was a bit of a challenge, but it in the end, I was very happy with the way the motion is. You'll see in a little bit, but same thing here. I've got lots of bearings that are in here.
Can you zoom up a little bit closer?
Yeah, you bet. Let me get situated here. Let me zoom in. Okay, so you can see there's a motor back here that moves the arm up, and then this has a servo that attaches to a rod that comes all the way down. We have a bearing that holds the weight, and then you can see right here is another piece of the puzzle. Again, these are all real parts. So this part is a real part. This is a pillow block that I got from a company called Octobotics. They also have all of their robot parts that you can download as STLs. So that is my pillow block. Then it comes down. Then we get into, again, just pieces. I think there's something like 500 pieces for this entire robot.
For the entire robot, it's 500 pieces?
500 pieces.
Man, I wanted to say, your wife is amazing, right? Your family's amazing. Like you said, this is not cheap, right? Too, right?
No, this is not cheap. And again, kicking myself in the butt for starting this robot as my first robot. It was just insane to tackle something on this scope. But I'm going to say it again. There's no way I could have designed anything like this on any other program. There's ZBrush. Look, I mean, all of these cavities, all this was all subtractive material. And I couldn't have done it without ZBrush and building these parts in. And anybody who says I could do that in CAD, we'll see you next year, because I built these arms like this and manufactured them, printed them, and put them together in 8 weeks. So it happens very quickly.
What's your magnets that you're using, and where do you get your magnets?
Oh, I will try to put a link. There's a really great 52. Their measurement of a magnet is in something newtons or something, but it's 52. They're super strong. I don't have these installed yet on the robot when I come to show you the robot. But you can see here these little round circles are for those magnets. So I also wanted these shells to come off for maintenance or to swap out a motor if a motor burns out, because you also have to think about how to maintain the robot once you have the robot built. You've got to get in there and fix something if something's broke. So without screws, again, I did everything with magnets. So everything, this outer shell will just clip right into this. Where each one of these little holes will magnetically connect together so that I can still access those by just simply pulling them off.
All right, I just wanted to give you a time check so you know you got 15 minutes.
Yes, 15. If I do another 5 here, and then I wanted to.
Yeah, there's one thing we're gonna all want you to do before you leave ZBrush, though.
Okay.
It might take a minute, but go on.
Okay. That's
the very last thing because someone's bringing it. I think it'd be cool to see. So.
Okay. Let's see. So then when all this is finished and everything's printing, I usually go in and do some poly painting. So this is a maquette version. I also printed up a maquette, so it's all decimated, and it's okay. I don't need it to be perfect. I just want to get an idea of where I want to throw some paint. So it's decimated, so I'm getting lots of. I'm missing all of my vertexes, so I'm not getting nice clean lines. But it's okay. Again, it's just about trying to get an idea of what I want to do, and then a lot of times I bring it into Photoshop. I'll photograph several of these. I think I have an image of that. Where is that picture? Oh, here it is.
You can go full screen on that if you want.
Okay. So I will take an image, a snapshot of the robot from different angles, and then I'll bring it into Photoshop, and I could then go through hue and saturation and change and just see if it's really amazing when you do change hue. It really changes different people's emotions. It's crazy. One thing I want to change about robotics is I really hate the black and white robots that exist everywhere. I'm like, there's a full color palette. Why the hell is everybody making black and white robots? I just don't understand it. And there's so much color and there's so much different things. And that's what I did with Alan and the lane of the robot heads, is putting as much color into them as I want, because there's just like, it really does evoke emotions in different kinds of people. So if you take the hue slider in Photoshop and move it back and forth, you can literally change both colors, the blue and the yellowy orange. And then you could go in and just pick a single color and change just that color. And so you can go back and forth with it. But this is like my color comping. I do the color comping while the 3D printer's printing. This gives me an idea so that I can start ordering paint to be delivered when it comes time to do the paint job, or do tests. Sometimes I just do a test on the maquette as well, because I print up a maquette before I go to the full robot, so I can take a look at it from all angles and make sure there's nothing that I want to change.
What's your technique for the panels?
For
you think the chest panel as an example.
Oh, that's a funny story. This whole robot, because I wanted it to be full-size robot,
yeah.
I actually brought in a human, or it may have been something that was already in ZBrush, and literally like smoothed it down so it was completely smooth. So this way it gave me like, okay, the shoulder joints here, this is the angle of the chest, this is where the head would be on a 6-foot person. And I used that chest blank, and I don't know if I got it.
Yeah, so you're taking an existing humanoid figure.
Yes, and
down.
Yep. And I think you're right here. Whoop, there we go. Can I go solo and frame? Yeah. So here we go. So this was it. I just smoothed this out, and I use this to make my panels on. I use a lot of different things. Sometimes I just will use an alpha, draw around, mask it off, and then
just masking it, extrude it out, or push it.
Extrude it out. Thank you. The word extruding just lost my brain. So I did that, and then just would go in and start putting my panels line in. The new chisel tools our brushes are amazing. I love those things. You can do so much with them.
So that's the brush I just showed people on the last one at the last.
Yes, that tool set, when you go into a higher Dynamesh, like since I'm doing everything in Dynamesh and going up really, really, really high, and then building all these lines in, those chisel tools are absolutely amazing. Absolutely amazing. And that's what I did. You know, some of these, there we go. So this was very old school, because this was 8 years ago. The Allen body, all this I did 8 years ago. So it's a little dated, and again, it was on 2K, which is why it's a little soft around the edges there. But a lot of this stuff was, some is alphas, some is parts, some are up here. I use B radius a lot.
Oh yeah.
I do use B radius a lot, even sometimes when I'm just concepting stuff, to kind of put these neat little lines.
Clipping or the slicing? Which one, with clipping or slicing?
Clipping.
Clipping.
Yeah. I use that a lot just to kind of move lines around. I like working very quickly. If I get, a feeling that that's the right way to go in, then I'll definitely go in that general direction. And then
you got about 10 minutes, so you know.
Okay, how much?
10 minutes.
Okay, got it. Okay, so another example, my son came to me and saw a Hexapod on TV, and he said, hey, make me one. So this was my idea for a Hexapod. I made this about 2 years ago. 3D printed everything. Perfect example of a fail. It got big, and it got heavy, and it just wouldn't walk. It moved, but it didn't walk. So on the YouTube channel, I'm going to revisit this again, and I've got bigger motors to go inside of it, and hopefully we'll get this to walk. But this is a perfect example of using kit bashing. I literally made all these parts in the body, and then all of this is literally like layering kit bash parts on top of one another in multiple layers to build up these parts. Like on this chest, these are literally just parts on top of parts on top of parts. Same thing with the head. Lots of parts. I know there's some robot people from some forums watching tonight, and this is, I explained to them that even if you take a while to get the grasp or understanding of how to use ZBrush and make your own parts, you can still do something like this where you can utilize ArtStation parts and put things together. I mean, this is like 60-70% of parts. Put it together and then put your motors inside of it, and you've got yourself an original robot. So perfect example of being able to kit bash and do something very quickly. I built this in 2 days.
What?
2 days.
That's pretty crazy.
Yeah, no, it's insane. And so
you design it, or did you just do it all and then said, "Here"?
I kind of designed a very something. I always sketch everything first. I start with paper and just kind of come up with real quick sketch ideas of what I wanted to do. I was just going to make a hexapod, and then he was like, "Well, what if we could put a man on top of it?" And then I was like, "Well, maybe I can incorporate like a buggy type thing." And then he was like, "What if his arm's a gun?" So I just started kind of like building all these different concept parts, and then I have to figure out again how everything functions, and then bring in the servos. So the thing that's missing here is there's no servos in those little slots where normally there'd be a servo there. But now I have to redo that because it didn't work out so well.
Awesome.
Yeah, and then sometimes I just go and do cuckoo crazy stuff. Like, I don't know what this is.
Hold on, okay, there you go.
Yeah, it's just kind of like you know, just kind of coming up with
got a mandible.
Yeah, just kind of, it's a, you know, gorilla bot. I don't know. It's just what
kind of got your own like mech skull thing happening there.
Yeah, and one of the things about my company Robomotics is that, you know, the idea is that the mechanisms, once you build the mechanisms, you could build anything. So here's a perfect example of Alan or Elena's head, shoulders and neck with the mechanism already built into it. And then you just snap off the head and snap another head on, and you don't have to rebuild the whole robot. You've got the mechanism there. You can just simply add a new head onto it.
Right. Yeah, they used to special effects and they would do that back in the 80s.
That's right. That's absolutely right. And so, you know, I use a lot of, and I know we don't have enough time to go into this, but I use a lot of pinch stuff, you know, for going in with yeah,
you pinch it up.
Yeah, pinch it up a little bit for S curves. I really like doing you know, stuff like that where you can get a really sharp line that it really works out fantastic after you dough it in. I literally go in sometimes and just like cut hard angles in, and then go back in with the pinch tool and just kind of like design stuff in that way.
Nice.
Okay, so let me go. You guys want to see the robots?
Yeah, but hold on. Go back to your ZBrush. I want to do one thing.
Yeah.
Your bartender. I want to do one thing.
Coming up. People.
Heavy. I think he's 90 million, 91 million.
Yeah.
Yeah. They were asking. This might take a minute, though, people. This might not be something instant. Can you go to transform and hit expose?
Yes. Let's see. Where is the
you've moved it. You've took it off the UI. So go up into transform menu at the top.
Okay. Yep. Transform. Got it.
And then find the expose. It's right next.
Okay. Here we go.
I don't know how long this is going to take because it's pretty dense. So
it's pretty dense. Okay. Here we go. I don't know what's going to happen.
You're not going to play because this will show them the breadth of your parts.
Well,
yeah.
There you go.
And you can do it in all 3 axes too. Right now, it's only doing it in 2 axes.
Oh, that's why. Okay, let me undo it, and then we'll do it again.
X, Y, Z in that. You see the little X, Y, Z above the slider, above the slider.
Above the slider. Yep, got it.
There you go. And now, if you click expose, it'll do all 3 axes.
Okay, here we go. Are you ready?
Yeah. There you go.
How come the arms didn't explode? That's weird.
I don't know if I ever tried to explode anything that large. You get a lot of parts in that one.
Yeah. There's some parts up here. That's crazy. But you know, everything, you know, even the platform that holds the bottles, it slides in and out on sliders and comes out the back and the back. I mean, just every little teeny part was all done in ZBrush. I couldn't have done it.
It's really
if
amazing.
I would have done it in CAD, it would have taken me, you know, it would have taken me forever, you know, to go through and do each individual part, and then I wouldn't know whether they were even going to fit together. You know, it just really is one of those amazing magical tools that just does everything. Because as an artist, I love being able to go into ZBrush and do something with some Jägermeister in my hand, and I'm doing some kind of organic doodle of some kind. So my brain go whoop, wherever it's going to go, and then for highly concentrated mechanical parts.
Is your exposed slider set to 100, Will?
What's that?
Is your exposed slider set to 100?
Let's check.
Is
No.
it? No, that's why.
Whoa! There's our problem.
There you go.
One more.
Hit frame again. Yeah.
One more. Not gonna do it.
It's too much.
It's too much.
Look, I can see it all over there. You got
look at
the
that
constellation right there. Yeah.
I'm zooming in. I'm zooming in. I'm zooming in. I'm zooming in. I'm zooming in.
Yeah, there you go, people.
Holy crap!
All these parts.
That makes me feel better for being tired.
There you go.
Oh my god!
All right, let's see these in action now.
Okay, let's go. All right, hey, let's come. Okay, here we go. Coming over.
Is this camera currently being controlled by a robot too?
I'm working on that.
Background, and the one for his son sitting up there in the top left corner right now.
Yep. Okay, here we go.
On the Emmy.
Yep, there's an Emmy and a Georgie.
Here we go.
Oh, there's the robots there on the wall. Nice.
Look at all the printers. Oh boy.
Mm-hmm.
Oh, boy's right.
Oh,
You sound like my wife.
Oh man, this is a great little. This is a
this
great space. Oh.
Yeah.
Oh.
Yes. All right, everyone's challenge. Follow
Okay.
Will. Let's all make robots. Follow Will. Let's all make robots.
Hey Alexa, what's ZBrush?
According to Wikipedia,
Stop it.
one is 3D/2.5
Stop it.
texturing and painting.
You're using Alexa that's sending to me.
Alexa, stop. Okay, so a couple technologies going on here. So,
Oh God, I have so many songs I want to put through that right now.
oh, I know, dude, it's insane. So Alexa is connected to my robot Elena, and then Alan has his own AI, but they're intermixable. You can take. I don't know if you guys know that Sam Jackson is now on Alexa in the United States. So I had Alan. There's actually one of my videos on my YouTube channel that has Alan channeling Sam Jackson, and of course, because I'm working in the film industry, I'm 1 degree away from Sam Jackson, right? So he saw it and sent a text that someone sent to me and said he just loved it and thought it was great. But so Alan has real AI technology being pumped into him right now. He has a camera in his forehead that you can see me. I'm holding my arm out. So he can do motion tracking. He can do all kinds of cuckoo crazy stuff like that. And he can tell if I'm my cognitive face, who I am. So he knows who I am. He can tell whether or not I'm happy or sad or neutral or disgust. And we can ask him a couple questions.
Okay.
He's different.
Yeah.
Okay, I got to turn off the pause button. There we go. Hello, Alan.
Hello there.
It's hard to hear him, but we see it.
Can you hear that?
It's very low. It's
Okay, yeah, it's very hard without me being right next to the robot.
Yeah. No worries.
What's your favorite movie?
Are they exactly the same?
Yeah, he's not, so you can't hear him. Okay, so now we're going to move over because I know we're running out of time.
What is his favorite movie? What did you put? What's his favorite movie?
HAL 9000 from 2001: Space Odyssey.
Yeah.
Me as smart as HAL in 2001.
He's
So
hoping to be smart as HAL in 2001. He just said. He hopes one day. Okay, I'm going to pause him. So.
He's correcting you.
I know he's correcting me. What the hell, right? Okay, so let me back out a little bit on this guy.
Yeah.
So here we're going to just turn him on. Give him a couple seconds to get up to speed. He's still product.
Are you controlling this, or is he?
No, it's all computer. It's all inside the computer. That's going to be inside him.
The next time I want to get something crazy and fun, I'm going to give my wife this video. Okay.
Joseph and everyone else who is watching, ZBrush is an amazing tool. Will was able to build this whole body for me in ZBrush.
I heard him say ZBrush is an amazing tool.
Oh, yeah.
And Will was able to build this robot in ZBrush.
And Will was
That's
able to
awesome.
build this robot in ZBrush. That's awesome. Will, this is awesome. I'm a big dork. I love this stuff.
We all are. We're like I said, we are a bunch of fan boys that are loving this stuff, and hopefully we're building the future. That's kind of the way that I'm hoping I'm doing something. If anything, I'm getting people to start thinking about robotics differently.
Yeah.
So we get rid of the black and white robots. Artificial intelligence is going like this.
Dice K just put your YouTube channel. People, here you go. Like I said, if you are enjoying this, you can talk to Will. How often are you on your YouTube?
I try to do once every 2 weeks, but I've had a break because I've had multiple things happening in my life. But
yeah,
I like to try to do one every 2 weeks if I can get to it. So the next one will be that putting the computer inside the robot, so there doesn't have to be an external robot. It's going to be built into the back of the robot with a touch screen, so I can at least push the on button, and he'll say, "Are you ready for a shot of Jägermeister?" And I say, "Yes, sir."
and then Alan's over there judging you, probably just like looking at you.
Yeah, he's looking at me exactly like, "Well, Jägermeister."
I would probably do beer.
He's like, "That's too many. It's too many."
Beer. What's the beer thing you have usually in the cart? I'm going blank on it right now.
The big keg.
But they have them. They call them something in particular. Like
yes, if you come up here, you have to learn it because in Portland, I forget what it's called too. It's not like a.
What the heck? I'm too far removed from college now. Kegerator.
That's it.
There we go. Kegerator.
Exactly. I mean,
that'd be a fun robot, man. Kegerator. Dude, we're all going to Will's house for a party. That's all.
Yeah.
We're all going to Will's house for a party.
My kids want the robot to do to hand out lemonade.
Oh my God, they would get so much. That's a brilliant idea.
So when this spring comes, because it's kind of cold up here in the winter, but when spring gets here, it's gonna be amazing. That video will be up on YouTube because that will be amazing. And then we always take the funds and give it to Children's Hospital or
that's awesome.
Jude's, which is great. We did it last year, made $400, but now we got the robot. Maybe we'll make 4,000. I don't know.
That's awesome. That's awesome.
Yeah, it should be good fun. Absolutely.
God, that's amazing. Great.
Listen, I want to say to Joseph the same thing I said to Paul, which is like, I want you guys to know that Ask ZBrush and Paul's segment has been invaluable to me. And everybody else. It's like you never find a software company that puts that kind of volume of material out. But every single episode that I've watched, I picked up something from both you guys, and I may forget it tomorrow, but then I can go back and watch it again. Right. But it's like, because my brain's like starting to go, I can't hold anything else in here. But it's like they're really invaluable to me, and I think everybody else could agree with me that they're just invaluable, and I appreciate you guys doing it. And it's like sometimes you say something, I go, my God, that's going to shave hours off my life.
Well, thank you so much. Your stuff's amazing. Amazing.
Thank you, guys. I really appreciate you having me on. I've had a blast, and certainly stay tuned on the YouTube channel because there's lots more to come. I've got like a tote board filled with like 3 years of robots.
Subscribers now, baby. You got some subscribers here for sure.
Yeah.
I love it.
That's awesome.
Alan's over there talking.
Thank you, Will. Thank you so much for number one, open up your house, taking time away from your family, setting up all these. Like we know, there's all a bunch of all that back end stuff that people don't know. All that work you put in just to make those all working and running for this. That's a lot. Thank you so much.
It is.
My pleasure, you guys. Absolutely, this has been a big, huge thrill for me. I've been a lurker for years, watching everybody do stuff, and you know, Rick Baker. Hey, I know Rick Baker. He's doing stuff.
Yeah. Yeah.
But I never thought that if I ever made it to the summit, that this is what I was going to be showing. Because you know, a couple years ago, I would have never said I wasn't going to be into robotics. It's crazy.
Man, that was awesome. Well,
yeah.
Honestly, I would want to sit and talk to you now keep going
forever. Yeah.
We got one more segment still for tonight, and we got to get to that one. But I thank you again, and we got to do some giveaways. I know people want to get some giveaways as well.
Perfect.
So everyone, please give Will a round of applause wherever you are.
Thank you, guys. Thank you so very much. I appreciate it. I had an awesome time.
They want to know what you won the Emmy for.
I won an Emmy for a TV show called Black White. It was actually where we took a black family, made them white, and a white family and made them black, and then put them into it was a reality show, put them into interesting positions to kind of talk about race in society. So it was a challenging show, and then the Georgie over here was for the General's Daughter way back in the day. And
I remember that movie. Yeah, I
remember that. That was what
John Travolta,
long time ago.
Yeah. Remember it. Well, thank you again. We will all be subscribers now, and
thank you.
Let's continue this camaraderie, people. This is what the summit's all about, man.
I know. Like you said, this could have never happened where you could go to all these great shops in New Zealand and all over the place and see stuff. You should do 2 summits, do one in LA, and then later in the year do another one where we're doing it virtually like this. Because it's amazing to see people's shops and stuff all over the world. It's amazing.
Yep. This has been awesome, Will. I really
appreciate you guys.
Yes, thank you so much.
Appreciate it. You guys have a great rest of the evening.
You too. Take care.
Okay, bye-bye.
Bye.